Hello everyone. Today my topic is analog and digital signal. First we are talking about analog signal. So why do we still study analog? The real world is analog. Voice, lights, heat, bit. Many of the input and output of electrical system are analog signal. Many electronic systems, particularly those dealing with low signal amplitude or very high frequency requirement, analog approach. Analog signal are continuous signal that vary over time and can take any value within a given range. They present information through variation in amplitude, frequency, or phase. So here is a analog signal wave, and the below one is a digital signal wave. If we use voltage to represent energy, analog signal wave should be smooth and continue over time. By smooth and continue, it means that within any range of analog signal wave. Digital signal wave look like we are drawing the graph of voltage over time. Viewed from far, the digital wave may look smooth and continuous, but they are tiny discrete steps. By discrete, it means for any range of digital wave, each value in voltage can be encoded in digital number 0 and 1. So we continue with the characteristic of analog signal. So continuity, analog signal are continuous in both time and amplitude. Representation, they are often represented by smooth waveform such as sine wave. Infinite resolution, they can theoretically have finite resolution since they can take any value within their range. So come to advantage and disadvantage. Advantage, high fidelity. Analog signal can represent subtle change in original signal, making them ideal for high fidelity audio and video. Simple process. Basic analog processing can be performed within relatively simple circuit. And for disadvantage, noise susceptibility. Analog signals are prone to noise and distortion, which can degrade the signal quality over time and distance. Difficult storage and transmission. Storing and transmitting analog signal without degradation can be challenging. In application, analog radio, television broadcast, one needs record audio telephone and a certain type of sensor. Okay, we are continue with the digital signal. Digital signal are discrete signal that represent information using binary code 0 and 1. They represent information by discrete step or level. The transition between this level occur at discrete point in a time, creating a square wave appearance. The signals are characterized by the square waveform, which switch between discrete voltage level and to represent data. So we go to characteristic. Discreteness. Digital signals are discrete in both time and amplitude. representation. They are typically represented by the square wave. Finite resolution. Their resolution is determined by number of bits used to represent the signal. And we continue with the advantage and disadvantage for digital signal. So advantage, noise resistance. Digital signal are more robust to noise and interference compared to analog signal. Easy processing and storage. Digital signal can be easy processed, stored, and manipulated by digital system like computer. Compression and encryption. Digital data can be compressed for efficient storage, encrypt for secure transmission. And disadvantage. Quantization error. Converting analog signal to digital can introduce sampling and quantizing error. Finite resolution. Digital signal have finite resolution which may not capture all the nuances of original signal. Application. Modern communication system, for example, telephone, Wi-Fi, digital audio, video, CD, DVD, streaming service, computer, digital camera, and medical device. Comparison. Summarize. For analog, infinite resolution within range, more susceptible to noise, require complex circuit for advanced processing, transition degrade over long distance, difficult to store without degradation. For digital finite resolution based on a number of bits, less susceptible to noise, easy and more flexible process with the digital system. Transmission maintain quality over long distance, easy and efficient storage with minimal degradation. And here is the analog vs digital signal. So we can see the big feature analog signal and digital. So feature is nature analog is continuous and digital discrete. And representation, analog is smooth waveform and digital is square wave. Resolution, analog finite and digital finite based on bit depth. And noise resistance for analog is low, digital is high. Processing more complex for analog and easy and more flexible for digital. Transmission susceptible to degradation for analog and maintain quality over distance for digital. And storage difficult without degradation for analog and easy and efficient for digital signal. So now come to a conclusion. So analog and digital signal each have their own strengths and weakness. Analog signal are excellent for high fidelity application, but are more prone to noise. In summary, an analog signal can take any value within a given range of time. Digital signal, on the other hand, offer robustness, flexibility, and efficiency in modern communication and processing, making them more prevention in today's technology landscape. Digital signal can only represent one of discrete set of value. The choice between analog and digital signal depend on specific requirement of the application. So that's all for analog and digital. Thank you.